Today we're going to pick up in section 10.4 where we left off last time, which is on 7C. If you'll remember, example 7 was talking about, I can get to it, good grief, normal distributions, and it was actually IQ scores. So it was mean IQ scores. We had 1,500 students. We were told that they were normally distributed with a mean of 100 and a standard deviation of 15. Using that information, we set up the 55, 70, 85, and so forth all the way across the bottom. And then I copied it to all three of my slides so that I wouldn't have to keep recreating the wheel. So on this one, it asks us how many students have an IQ between 70 and 145. So as we take a look at this, we'll shade it in. So here's my 70 to 145. And what I hope that you notice as you're shading that in is that it's unbalanced. So on the first one, for example, it was one standard deviation to both sides of the mean, so it was a very balanced picture with the empirical rule that we have. On the second one, it wasn't balanced, but it was just 1/2 of the end, and so we were able to divide by 2. On this one, it's not balanced, but there's sort of one portion of it on one side and one portion on the other side. So what I would like for you to remember, though, is that we know that there's 68% here, right, with one standard deviation away. We have 95% to 2 standard deviations away. And then 3 standard deviations away was 99.8%, right? So it's going to be somewhere between 95 and 99.8, right? Because I'm 2 standard deviations away if I'm here, which it's definitely more than that. I've got extra shaded in. But it's not quite hitting all the way out here, which would be 99.8%. So it's somewhere in between the two. But it's not necessarily halfway in between, it's just in between. So what we can do instead is we can remember or recognize that symmetry fact that's going on here. And Gracie, I have yours. So if I have 95% to get me 2 standard deviations away, right? And I only want to look at this half of it. How much is over here on this half? What would it be? Okay, so how did you get that, Emma?
95 divided by 2.
Right. It's half of the 95, right? It's just the left half of that 95. And we can do the same sort of thing if we go over here on the other side. Let me change colors. So instead of it being all the way 3 standard deviations in both directions, it's only half of the way. But 3 standard deviations was 99.8, so I can do half of that as well. So that's my right-hand side half. And if I were to add these two pieces together, I would be able to find what percentage it is overall. So grab calculator. We're going to do 95 divided by 2 plus 99.8 divided by 2. And this is, of course, the percentage of students that lie between those values. $97.4. Sounds good. 97.4%. So is it between 95 and 99.8? Yeah. It's a good thing to sort of just mentally check to make sure it makes sense, and it does. Now, again, on this problem, it did not ask us to find the percentage. It asked how many students, right? So we've done this a couple of times now. We set them up as proportions before. We have 97.4% this time. So 97.4% or 97.4 out of 100 is my number of students, which I don't know, out of the 1,500 students total. So we can cross multiply. We have 100x on one side. I don't have the in-between calculation written down, so we'll find it. 1461 on the other side. And then dividing by 100 would give us 14.61. 14.61 what? Hang on. Oh, I know what I did wrong. I'm so sorry. I have 2 decimals missing. I just wrote something in our, this is 2 zeros at the end, wasn't it? My bad. All right, good, 1,461. That matches my notes, that's always good. 1,461 students. Okay, so that was the end of the normal distribution stuff they didn't quite finish. We have one more piece of information in this section of material, though. Any questions about the normal distribution type questions? Okay, the last piece in this section, as it relates to variance, central tendency and variance, is percentiles. So percentiles, these show a person's score relative to other scores. For example, a score in the 90th percentile means that approximately 90% of all other scores are lower than this score. So there's lots of things in your life that you're going to see done in percentiles. Someday many of you will have children and you will take them in and the pediatrician will measure their head. And they'll measure their height and they'll measure their weight and they will tell you things like they're in the 50th percentile. They're in the 10th percentile. My little girl, the one that you've met, her weight is still, her BMI is still in the 3rd percentile because she's about this big around. You guys remember that, right? Yes, she's really, really thin. So they measure those to make sure that their height and their weight are matching up, for one. Also that there's not something alarming. At one point, one of my children's head circumference was measuring far too large. So they kept an eye on that. They were looking at those percentiles. So that's one area where you see them used frequently. Another area is in standardized test scores. So when I was a student, we took what was called the CTBS test. And then it changed to the ITBS test. What standardized test did you guys take? SAT, ACT, but when you're children, do you remember?
I took math testing.
Okay. Do you guys remember any of the others you took? Tax? Okay. So when you get those standardized test scores back, they don't tell you how many you got right and how many you got wrong. They don't tell you how good you were compared to the test itself. They tell you how good you were compared to all the other kids that took it. Did you know that? Did you realize that when you were looking at it? It's a very interesting comparison because that means that half the students have to have scores 50% or below, right? They have to, because that's what percentiles do. They measure you against other students who took the test. So you have to be careful of what you're actually giving a percentile. Is it a percentile or is it a percent of something? So here's an example of a question that sort of intermingles these ideas, and we want to be very careful how we're thinking about it. Junior was ranked 50th in his graduating class of 325 students. Liz was in the 75th percentile in the same graduating class. Which student had the higher GPA when they graduated? Okay. They both say a number with a TH, right? But they're not measuring the same thing. In particular, Junior's 50th in the graduating class is telling you that he was the 50th in line, right? There's 49 people better than him. Are you with me? But Liz's is actually telling you not that there's 75 lower than her, but that there's 75% of the people who are lower than her. Okay, everybody good on what's this actually asking you? All right, so we're trying to figure out who is, the better student GPA-wise overall. And we have a couple of different ways that we can do it. We can either figure out where Junior is in his percentile, right? How many people are below Junior? Or we can figure out where Liz is in her ranking. And both will answer the question equally well. We're just calculating it in slightly different ways. So do you guys want to work with Junior or do you want to work with Liz? Liz, okay. So if Liz is in the 75th percentile, it means that 75% of the people are below Liz. And there are 325 people. Okay, so far so good? So what we're actually going to find when we do this is how many people are below Liz. If you wanted to, you could find how many people are above Liz. How would I change the expression here if I wanted to do that? A little bit louder for me, Emma. Nope, not put the 325 on top. Good guess. Yeah. So if she's got 75% of the people below her, she's got 25% of the people above her. So you could put the 25 on top. okay? So I've already got it set up, so I'm going to go ahead and go with it like it is, but that would be another option. All right, so we'll cross multiply. So we have 100x equals, and now we need 75 times my 325. 24,375. We'll divide by our 100. Obviously, we don't really have 243.75 people. That doesn't make sense. We're just going to use regular rounding rules for what we're doing. So this is approximately 244 people. So these are the number of people that are below Liz. Just for fun, let's actually calculate that against how many people are below. How many people are below, what was the guy's name? Junior. How many people are below Junior? How many? Yeah, we've got 50 above him, he's the 50th. So how many people are below him? 275. So I realize we're off a little bit because he's the 50th, so there's actually probably 270. There's actually 49 people above him, 275 below. So yeah, so who's the better student GPA-wise? Is it Liz or is it Junior? Junior, because he has more people below him. Likewise, like there's lots of things we could think about in writing this problem down. We didn't have to do it as people below. We could have used Liz's 244 and figured out how many people are above her, right? And we could have made that comparison. Or we could have started differently and we could have looked instead for Junior's actual ranking instead of looking for Junior's actual percentile instead of looking for Liz's ranking. Okay, does that make sense? Awesome. All right, so this assignment is now complete. This one will be due next time. I did go ahead and get Canvas adjusted on that, so you should see that out there. We'll do questions from it next time. So we're missing a few people, but what I need for you to do is I need for you to get, let's see, 2, 4, 6, 8, 10, 12, 14. I need you to get in either groups of 2s or 3s. It doesn't really matter to me. Go ahead and turn desks because you're going to need to work a little bit together because I don't have enough manipulatives for you each of your own. Okay? So let's do that.